signer for Web3. Yeah. Signex is like DocuSigner for Web3. So we recently launched on Solana Hacker Houses, and there many people approached us, and they were like, "It was a pretty cool idea." So we are currently building our MVP and stuff like that. Yeah. Now over to you, Sneha, if you would like to tell something.
Hi everyone, I'm Sneha. I'm also building something. I'm building something known as Social 3. So this is a social hiring platform that we are building for Web3. And basically the problem being in Web3 that a lot of the folks are trying for opportunities, but they're not able to present their work experience, Web3 based work experience. So we are building a platform that can actually take into account all of the transactions, all of the educational NFTs that you own, all of the DAOs that you're part of, to construct like a one glance Web3 sort of a profile. And then we also provide like referent talent on crypto model. So yeah, that's also something that that's going on, and we are also like building the MVP for it. So.
All right, that's amazing, guys. I'm just gonna share my screen and introduce about Phoenix Build for anybody and everybody who's new and who's not aware of it. So basically, Phoenix Guild is a guild that is for women by women. What we do ideally is help women get onboarded to Web3 through education, because we believe that education is the key for anything and everything, right? So that's what we do. We conduct sessions. We are a diverse and inclusive Web3 ecosystem, and we want to create an environment where women are able to come and like create and work on their own projects, right? So that's, sorry, give me a minute. So it was started by the four of us, Krati, Gyan Lakshmi, me, Sri Lakshmi, and Nivedita. It started off because all of us were pretty passionate about the cause and about diversity and inclusivity in general. And we thought, let's come together and start a guild. And that's why we began. We started in the mid of June. And we started off with a grant from Ocean. And now, thanks to the whole Solidity Bootcamp, we've partnered with a couple of more protocols as well. So ideally, we do onboarding sessions. We help women come get onto projects. We help them get interconnected, and we also help them in terms of attempting bounties and solving questions. I mean, solving problems that they have in terms of Web3 itself. So ideally, it is for everybody. Our participants at the bootcamp, especially women, specifically women at the moment, but we are trying to include more and more mentors and from all aspects here, and it is for anybody and everybody who's interested in the whole education and who's curious about Web3 itself. Right. So that was a brief about what Phoenix Guild is and what we do. I'll share our Telegram on the chat as well. And I would like to now hand it over to Sneha and Siddhanti so that they can take over for the session.
Hi everyone. So today we have something pretty interesting planned. Gyan, can I have the share screening option? It's not accessible to me.
Just give me a minute. Yeah.
Okay. So I'm just gonna show you folks what we have going to build today. So can you see my screen?
Yes.
Awesome. So we have made it so far into this bootcamp. People who are part of the bootcamp, people who are joining us and a part of Phoenix Guild from now on. So what we're gonna do is that we're gonna create a dynamic NFT today, and we're gonna create it based off an avatar. And what it's gonna look like is that here's what I want you to do. So basically, you put your name here, right? This will actually show up on your OpenSea when we actually mint the NFT. This will be the description. So like you can write something cool about yourself and how this experience has been here at Phoenix Guild, how the workshops have been, something like that. And here you basically choose the style of avatar that you want. and it will just randomly generate something based on that. I personally like the Cruddle one a lot. So what happens next is that, okay, if we select the Cruddle one here, so it will just ask me to download SVG file. Not sure if this is visible to you or not.
No, the external clicks are not visible. Okay.
Okay. Do you want me to share the whole screen then maybe just show that? Uh, should be here. Okay, so I'm just gonna upload and show you how this looks like. So I've just selected adventurer and neutral here. So this is basically more of the general neutral sort of an avatar, and uh, just gonna upload this. And then I'm gonna try and end this. Okay. Is the MetaMask notification also not visible?
It is visible. It is visible.
Okay.
This is the blue one.
Yeah, just click on it.
Yep. So basically, this is what we're gonna do. We're gonna create a dynamic NFT, and when we click on confirm, this is on the Polygon Mumbai testnet, and just gonna wait a minute here for the transaction to get confirmed.
The MetaMask window is not visible actually. The only notification bar is visible.
Okay. Okay, this will just show an alert. I'll just share my screen, stop sharing, and then share again with the complete window. But just give me a minute. Okay, so as you can see, this will just okay. So as I said, just put your name, select an avatar, and the description that I'm happy to be here. So that is how we're going to do a dynamic NFT for now. And the next thing that we're going to work on for today is a Phoenix Guild gratitude board. So all of the folks, we have been, so far into this journey, and there's this time that we have to be grateful to all of the awesome mentors and all of the cohort mates that help us make this a very wonderful and less painful, less boring experience. So what we're going to do is that we're going to send a little matic to your favorite mentor or cohort mate. Well, basically, you need the wallet address for that. So maybe you can do that afterwards and just try this app out for yourself. And here you can just enter the amount in Phoenix Heart. So this is the calculation, by the way. So I'm gonna give let's say 5,000 Phoenix Hearts, and receiver address for the time being. I'm just gonna put another account of mine just to show you. Uh, okay, awesome. And this is all the love that I have for Gyan here, by the way. So you can choose anyone that you want to, and just gonna create the submit button, and then we're gonna see how this transaction looks like on the Polygon testnet. Okay. So again, this is another MetaMask confirmation. I'm really sorry that you cannot see it right now. After the demo, I'll just stop sharing and then share again with the complete screen. But I'm just gonna wait for a minute here for the transaction to get complete. Okay, so it says confirmed, and okay, 1 second. For some reason I'm not getting the. Okay, it's still mining. Wait, this is a transaction right here. So the transaction is still in the pending state, so I'm just gonna give it some more time. Polygon testnet being a bit slow today. Try sending another transaction. Okay, this is still processing. But yeah, till then, let me just talk a little bit about how this whole flow will look like and what we'll talk about. So, as you can see, we're gonna first cover a NFT-based smart contract that can allow us to take all of this information and actually put this on chain. So I do remember that some of you folks have attended a workshop by Filecoin, where you folks learned how to store things using NFT storage on the IPFS. So we're going to do something of the same similar sort here as well. And then for this gratitude board, we're going to work with another contract, and we're going to see on how we can actually transfer value from one. Okay, yeah, transfer value from one person to another based on their based on their wallet addresses. Okay, I'm not sure this is still in process for some reason. Polygon testnet being very slow right now, but okay, let's come back to this later on. Okay, so let's talk a little bit. Yeah.
There's a bit of background noise that we can hear consistently. I think
Yeah.
sitting close to a fan or something.
Yeah, just give me a minute. Yeah, is it better now?
Yeah, it's better.
Yeah.
Awesome. Okay. All right. So coming back to this. Yeah, I'm not sure why the Polygon transactions are not going through. As you can see, just saying please wait. But let's move on to the coding part, and let's see how interesting this whole thing can be. So first, I'm gonna stop sharing and move on to sharing my code editor. So let's get started. Okay, can you folks see my code editor?
Yeah.
Yeah.
Awesome. So let us first start with the NFT minting contract. So I'm just going to talk a little bit about the ERC721 standard and how we are planning to use it here. So I'm sure a lot of you folks would have already seen a lot of this, like used a lot of this ERC721 thing already, building applications. But here we're going to use a very special case of ERC721A, which is ERC721 Uri Storage. It's an extension to your normal ERC721. And the reason why we are using this is because we plan to build a dynamic NFT. Meaning that our metadata URI, that is our name description, as you saw that we are taking as input fields in on our application, we are going to infuse this into our application instead of like having it saved already. So what you see normally in your NFT based collections, so that data is already saved and marked as, okay, token number 1 will have this particular URI, token number 2 will have this particular metadata. But in this situation, we are actually minting it dynamically. That is, at that particular moment, we are actually sending the name and the description, and then we are getting the data, right? So for that reason, we are using this ERC721 URI storage file, which will allow us to mint this URI and set it here itself, rather than having it like the other way around and having it already being set. So let us see how we're going to do that. And this is another import that we have here, which is the counters.sol. This will allow us to keep a count of all the token IDs that is actually being minted. So this is just like we are just going to use it to increment through our code. So just like if all of you folks can just write down in the comment section, if like have you folks used ERC721 before? Or should I explain a little bit more about how the ERC721 works in general? So we can talk a little bit more about that, or we can continue with other stuff as well. Do let me know. And also feel free to stop me at any point of time if anything. Okay, awesome. All right, so ERC721 is basically the standard that we use for NFTs. And if we talk about NFTs is basically just maintaining some metadata on chain. So here in our example, we saw something like the name, description, and the image, right? So whenever you see an image and that you say that, okay, this NFT, we can just copy this and something, but that is not the logic that goes behind it. Because all of this metadata, it is actually stored on chain. We are first going to upload this on IPFS. IPFS is basically another technology which allows to make storage decentralized. So no one can actually like take down the IPFS based storage, and the NFT technology. So the 1 second. Okay, yeah. So what we're gonna do then is that we're gonna map our NFTs through this contract to the name and description and the image data that we're gonna actually store. So where that mapping will happen on the front end, I'll talk about that later. But this is basically just a little bit about the ERC721. Whenever you talk about a collection, if we just go iteratively over all of these lines, so first we have all of these import statements. Then you're talking about the contract. This is ERC721 URI storage, means that we are inheriting this particular class. So I believe a lot of you would have already learned about inheritance in your prerequisite learning. So what this will do is that this will just take this file and we'll just find this particular class, and this will actually inherit this and use it. Like the functions defined here, we can actually use it. We can override the function. So that is basically the why we're writing is ERC721 URI storage. Then if we talk about the counters, as I said, this is just the standard way of writing the counters. This is just a counter that can increment and store the token ID, the particular token ID for that NFT. And this is an event. This is an event that we can throw. So events are basically like whenever you create a new NFT or whenever a new action is being created, to log it or to show that so that the front end can actually listen for, okay, when this event is complete. That is why we need an event listener like this. So you might argue that why are we using an event listener here? We should get the response instantly, right? We can just save it in our database, so we can do something like that, right? But here, when you're talking about blockchain transactions, we do not get the response instantly, like whether something is, whether the mining is being done or the block transaction is complete or not. As you saw in our example right now, when I was trying to mint for Polygon, we did not get the event like at that very particular time. We did not get the response. So the response comes after some time. That is why you need to have someone listening to understand that, okay, this is when the NFT is being minted or the blockchain transaction is complete. So you can think of it like if there is like a game in your country, like any particular sport, and many times you will just set up some alerts on your phone, right? That, okay, whenever a particular score or whenever a particular thing happens, that you can just check out that, okay, all of these notifications are there. So there is someone listening there, and then, okay, these are all the events that are happening. So you can think of that the events like this, all right. So this is how we're talking about the event. Now, if we see the constructor here, so the constructor that you normally know, normally in code, constructor is basically the function that is called whenever that particular like instantiation, contract instantiation happens, or the object is being created. So this is when that constructor is being launched. And here we can see that we have some two params here. It takes two params, token name and symbol. Okay, so what does this token name and symbol imply here? So token name basically talks about the name of the collection that we want to keep, name of the NFT collection. All right, so we would see how we are passing the values in this constructor as well. And the symbol basically implies whatever symbol we want for the particular token. So a lot of you folks have been introduced to crypto terminology, right? So if we talk about Bitcoin, so you have heard the symbol that Bitcoin is BTC, Ethereum is ETH. So this is because this symbol is what actually that BTC or that ETH represents. So we can keep something short like the initials or something here as the symbol, right, for our token. Awesome. So this is basically how we can set it. And here this token name and symbol is actually then passed to our ERC721 token name symbol. So you must be asking like, okay, but what is happening here? Like, okay, this is just only this particular code is here. Where is this value being set? So this is actually being set in our import file itself. So if you'll go and check out OpenZeppelin's code here for ERC721, you can see how these values are being taken and set here. So I kept the constructor empty for now. What you can actually even do is that just write a console.log statement here, console.log creation, maybe something like that. So we can just add a console.log statement here as well. But I'll just remove that. If we can actually add anything here, like with whatever suits. If there are other things that we need to set in the constructor, but in our particular example, we don't need to do here anything. Anyone having any questions till now, please feel free to ask. Or if this is clear, I can just proceed with the next part of the code.
Sneha? Oh, how do you pronounce your name?
Sneha.
Sneha. I have a question. In line 15, when you set
Yeah.
the constructor, you in the end write also ERC721.
Yes.
Why is it necessary? Because I understand that the constructor is the constructor for the ERC21 Uri storage that was set in the contract statement.
Correct. Yeah.
Right.
So
Why you
basically,
have
yeah. So basically, the ERC721 URI storage is an extension of the ERC721. So when you will actually open the code for these files, let me see if I can even show those to you. Give me a minute.
I'll try to pull up the OpenZeppelin.
Yeah, that's what I'm also opening. Just give me a minute. Oh, let me share the screen.
Yeah, I found the GitHub. Let me paste it in chat. So, if you see the screen, yeah.
Yeah, so as you can see here, this ERC721 URI storage actually extends from ERC721. As I said, what does is mean? Is means that they are inheriting from that particular interface or from that particular class. So since this is already being already has ERC721 code available here, so we can write that in our code and that won't throw any errors. And if we want to talk about that token name and that symbol thing and how that is being set, then we can actually check out ERC721. And if we go to the constructor over here, so as you saw in my code, this name and this symbol was being passed on to the ERC721, correct? And that is where this is being set over here. And that's where our constructor is empty because this is being set by adding that. Does that make sense, Sylvia?
Yes, but why you have to specify ERC 721 in the constructor line?
Yeah, because I want to set the token name and the symbol of my particular collection. So let's say I want to name it Phoenix NFT collection, and like have some the symbol be like PNFT or something like that. So to set that, I can do that, and then you can actually see on the OpenSea. Let me just show my OpenSea. So can you see it over here? It says NFT Phoenix V2. So this is actually what I'm setting in my constructor to get this value. And that's why I'm setting it there in my constructor.
Good. Thank you.
Awesome. Thank you, Sylvia. All right. So I'll just continue with the rest of the code. Okay. So moving on to the remaining functions over here. So we have a base URI. Yeah. So we have a base URI function over here. So the base URI is basically the URI that is like the base plus the token URI constitutes the complete URI that the token ID for that particular token ID where our asset will be, like where our name, description, and all of this will be. It'll point towards that. And as I mentioned earlier, we'll be storing all of this on IPFS. That is for decentralized storage so that no one can essentially take down whatever content we try to put up there. Right. So that is why we're just putting a base here as IPFS and just like a nothing like that, just like an empty IPFS string over here to just set the base URI. You'll see how we'll be overwriting this through our front end to get our actual IPFS data as well that we're going to get after uploading using IPFS filecoin Nft.storage technology. We'll replace this base URI plus token URI ID with that particular IPFS, and I'll show how that whole thing works. And then we finally have our most important function here, which is the mint token function, right? So if we see the function mint token, then it takes an address owner and a string memory metadata URI. So as I mentioned before, this is going to be a dynamic NFT. So we are going to provide it the metadata URI, that is we are pointing it towards the asset which talks about the name, description, and image, what we are taking in our front end, correct? So that's why we are passing this link there. And the owner is basically the person who will be minting this NFT to. So that will be the NFT owner, right? So what we are doing here is that we're just incrementing the token IDs. We're getting the current token ID. So you might be asking, where is this increment or is this current function coming from? Same logic, we can just go and check out GitHub of this particular utils counters.sol file, and you can find all of these inbuilt functions over there, and you can see how the logic looks like. It will just be like incrementing would be +1 and current will be just getting that at that particular like length -1, whatever token ID is present, right? This safe mint function is also an inbuilt function that is accessible to us, and this is the actual minting function. And this is present in our ERC721 contract, where we are passing the owner, that is the owner of the NFT, and the ID, the token ID. And then we have the set token URI function, which has the ID again, and this has the metadata URI. So this will set our token URI to point towards that particular asset with the name, description, and ID. And I'll show you how this looks like. It'll just be a JSON file on IPFS, and we'll just be putting the link of that file here so that we can set our token URI. And this is our use case of using ERC721 Uri Storage, because this set token URI function is not accessible in our normal ERC721. That's why we are importing this particular ERC721 Uri Storage extension. And as I mentioned before, that if we are talking about a sport, then we have this particular event thing that we want someone to continuously listen to our event. So here we have just declared this particular event new NFT minted, which has address sender and this particular token ID. So when this particular event happens, that is in function mint token, that is when we'll throw the event that, okay, this NFT has been minted, let us emit or let us throw this event that, okay, this has happened. And we will pass again this owner and ID. And this will be accessible on the front end for us to actually see and then make use of to like put an alert message or something over there. So you saw some alerts, right? That were just given like, okay, you have minted this and this is the testnet ID. So we can actually listen for this particular event and we can get the owner and the ID variables from here to use in our front end. So we'll see in a little bit how this whole thing works. But any questions so far? Any other questions? Okay, I think we are good then. Awesome. So I'll talk about, okay, so now we have our min.sol file already, and we have a min token function, and we have set other things here as mentioned. So how do we actually deploy this contract, right? So if you folks have already worked a little bit around hard art, so you would know that, okay, in the scripts, we will have a deploy script. And under the script, okay, this is just some gibberish I have here. So I'm just going to remove it. Yeah. But under this deploy script, we have a very standard deploy thing where we are using the ethers.js library and we're getting the signers here. So what are signers, you might ask? Signer is basically an abstraction which can allow us to like have control of a particular account. Like it basically gives us some sort of ability to sign transaction. That means that we are kind of in control of that particular account, or we kind of have access to that private key. So by getting the signers here, these are the two accounts that we are getting here from here, like, okay, owner and then super coder. So we are getting the signers, that is like all of the accounts that you have, the 0th and the first account, we are just getting that from the signers. And then what we're going to do is that, okay, we are just getting the contract factory, NFT minter, which is like the name of our contract. If you see here, we have named it NFT minter, and then we are just deploying it. And I mentioned, right, that we have a constructor and we have a token name and symbol. So you can see how that token name and that symbol is being passed over here to deploy the contract. And then we are just, okay, why are we using await everywhere here? Because we are actually waiting for this action to be completed before moving on to the next line. If we don't write this, then if you try to do any of these actions, most of the places will get NFT contract as undefined because the value is not available till now. The action is not complete. So await is a way to say that, okay, wait till this action is complete, then we'll get the value, and then we can actually access, like if you see the console.log, it will show the NFT contract.address. So any questions till this point?
Please keep adding in the chat if you have any questions related to the contract and such. I think Sneha will also be able to share the code, probably the GitHub link post the workshop, and we'll be sharing the recording as well. But yeah, if you have any questions and you don't understand how this contract works right now, yeah, okay, there are questions coming up already.
If you're using await, why have it as async? So that is actually like await keyword is used in conjunction with async. So if you don't use async there, this will actually throw an error. So you have to define it as async block and then use await inside of it. That is how the JavaScript code works. And I've also pasted the GitHub link to my repo. Okay, any other questions? Or we can actually move on to the front-end part and see how this all thing, like everything is like coming into picture. Do you folks want me to actually, yeah, deployment, yep. Do you folks, so I've already deployed this on the front end with my contract, but if you want, I can actually run the command here and then show you folks, and then we'll replace the whole thing on our contract and see how this thing works. All right, so let me just open a terminal screen over here. Okay, so first I'm gonna make sure that my node version 16 is being used. And then what I'm gonna do is that I'm gonna write npx hard hat run scripts/deploy.js. So this is just, okay, I made a mistake in hard hat. Yep. So if I run this, I'm just gonna wait for a minute for it to run. Okay, so as you can see, it says compiled 14 Solidity files successfully. There are some errors here. No, sorry, not errors, warnings here. We just talk about an unused local variable, this one, and it talks about the function state mutability can be restricted to pure. I'll explain what are pure and view and all of these functions in a bit. And but in our last line that we saw, that contract deployed to the contract address, you can actually see this address being output here. So which line? This particular line, console.log contract deployed to this address. And this is our final contract address that we get over here. Awesome. So this is basically more or less how our function looks like. Also talking a little bit about what we saw earlier also, in terms of the view and the return functions. This won't be, these are not used in this particular contract, but we will look at them in our gratitudeboard.sol file. But for now, I'll just move on to the front end, talk a little bit about how we are doing things on the front end, and then we can come back and discuss on our second part or on the gratitude board on how view or pure or all of these functions work on Solidity. All right, so now moving on to our React application. So, okay, as you can see, there are a lot of imports for all of the UI elements that we are being that is being used over here, and then we have some normal state management set over here. So what we are basically doing in terms of connecting the wallet or actually making the first connection. So let me just show you first on our application what this means. Okay. So let me just take a reload of this page. Okay. Okay. So as you can see here, this shows Mint NFT over here, right? But let me just actually remove this localhost 3000 from my connected sites to show you how this will look like when we are not connected and we have to make the connection. Just give me a minute. The MetaMask is being a little slow. Okay, this is on account 2. Go to account 1. And okay, all right. So I have disconnected this account, and now if I try to take a refresh for this page, it will show you something like connect to wallet over here, right? So what happens when we are trying to connect the wallet here? So let's check over here. So this is our implement connect wallet method. So for like whatever time we have here, I won't be talking a lot about the UI elements right now. I'll be focusing more on the wallet connection part, and then actually the minting NFT part, how we are calling the functions and all of those things. But feel free to reach out to me if you have any questions around the UI part as well. Like you can just hit me up on Twitter or yeah, like my GitHub is also shared. So just yeah, feel free to ask any questions that you might have around this. So if you're talking about a connect wallet method, so our Ethereum object is actually present in the window. So this Ethereum object basically gives us access to our MetaMask, right? And what we are trying to do here is that first we are just getting this Ethereum object that is embedded within our window. And if it's not present, then we are just alerting that, okay, MetaMask is not present. And if you're talking about the next lines, what is happening here? So we are getting the chain ID, which is like we are right now on Polygon Mumbai testnet. So what we are doing is that this is an Ethereum request where this is like the standard code where we're just sending the method to get the chain ID from this object. This is already like this object, Ethereum object already has access to this ETH chain ID, and this is the way we are requesting for it. And then we are comparing whether this chain ID is correct or not to the Mumbai testnet. Okay, this has written Rinkebai, but just ignore that for now. But we are just checking whether this is connected to the Mumbai test network or not. And if not, this will throw an alert over here. So how does this actually look like? Let me just show you if I try to change. Okay, again, MetaMask being a little slow. Just give me a minute. Sorry. Okay. Okay. I thought there were some questions. Okay, fine. Going back to the code then. Just give me a minute. Yep. Okay. So I think I changed the chain ID. Let me check. This is taking a minute to load. Please bear with me, folks. But yeah, and if I take a reload right now on the page, then as you can see, this is giving me the alert because my chain ID is not matching with the Mumbai Polygon test network. I changed my network to the Binance Smart Chain network. So you can actually set up such a alert on your application as well to make sure that they are connected to the right chain before they start to work on it. Awesome. So now moving back to our code that now we have, okay, the chain ID set, then we are actually getting the accounts, right? So the accounts by accounts, we just mean basically the public address, the wallet address. So I have a lot of console.log statements here to show you how we are setting. So again, as I mentioned, this Ethereum object has a lot of this data. So you can just actually go and check on all of these methods over here. I'll share some documentation as well. Maybe I'll just put them as on the README to this repo, so you can check out all the different methods that are accessible, like ETH_request accounts, ETH_chain ID. So you can just change that and then access these accounts, and then you can just console.log it. Okay, connected to this account. Then we're just setting the current account. This is again state management that is present within React, which is just setting the current account value to this account 0. And then you see another function here being called setup event listener. Before I talk a little bit about this, I'm just going to show you how this would look like if I do it right now. So I'm pressing on connect to wallet. My MetaMask will pop up. And this is again another learning that all of us need to have whenever we try to connect to accounts. So sometimes you can find all of these scammy websites and everything, and you don't know, and they just put like connect wallet or some other things. That always try to read this notification. Since we are all working from the perspective of developer now, you can actually understand and then see that, okay, whether whatever things that they are trying to do, is the transaction safe or not. This is something that we have to keep in mind. And just to show you how this will look on the console as well. Yes. So as you can see, some console.log statements, which says that connected to chain this and connected. And this is my public address that you just saw over here, right? On this connected console.log connected accounts 0. That is the 0th account of all of my accounts on this particular MetaMask. Just fetch the public address of that, and that is what we outputted over here. Okay, awesome. Then I spoke a little thing about the setup event listener, right? So does this ring a bell? We just discussed a little bit about the events and everything on the smart contract side, right? That we are going to have a particular event. We are going to call it new NFT minted. And then our front end should actually listen for this event, and then they will be able to use that information in any sort of way, whatever values that we are passing there. So this is exactly what we are doing. This setup event listener is basically our way of like capturing this event. And how are we going to access this? Again, we just take our Ethereum object from the window. Then we see something over here which says provider, signer, connected contract, ABI, a lot of these foreign terms. So let us break down all of this one by one. Okay. So if you're talking about provider and you see something like new ethers.providers.web3 provider, and we are passing Ethereum here. So this ethers versus ethers that you see everywhere, we are just using ethers.js library. So Ethers.js library makes it very easy for us as developers to communicate between the front end and the smart contract. And we are using this library to like make sure that that interface allows us to like read from the blockchain, write to the blockchain, get information. All of these things is possible using the Ethers.js library. So all of this documentation I'll also share with you on Ethers.js, so you can actually read up on how these things are happening. So then we have something called the Web3 provider. So what is the Web3 provider? Let me actually just open up that page. I have actually kept it here so that all of us can read and understand. So some common terminology: provider, signer, and contract, and how Ethers.js enables us to communicate with all of these elements. So a provider, it is an abstraction that can allow us a connection to the Ethereum network. This is what this does. This is for connecting to the Ethereum network, and that is why we're passing the Ethereum object here. That is our MetaMask, which is our like the provider in this case. So if you use another wallet other than MetaMask, let's say you want to use Coinbase wallet, then this is the point that you change. The provider, you will have to pass something that is like a Coinbase made provider that is accessible to you. So you can actually search for certain libraries or things that they have open source to allow this sort of a provider that can enable connection to their particular wallet. So this is how you can access this, but this is just a connection to the Ethereum network. What is a signer? So signer is basically a way that directly or indirectly has access to private key. So I just spoke about this a little bit ago on our backend, on our smart contract side as well, when we were looking at our deploy.js script, that this can allow us to sign messages and transactions to authorize the network, right? So this is basically the way that we can just like complete our transactions on the blockchain. So through the signer, we can also get like the wallet address and other elements here. We can just use this to perform all sorts of operation. And what is the contract? The contract is again an abstraction which allows us the connection to a specific contract that is present on the Ethereum network. So this is how this whole thing looks like, what all of these things work. Provider, our connection to the Ethereum network. Signer, that enables our transactions on the Ethereum network. Contract, pointing to the specific contract that is already deployed on the blockchain. Okay. Any questions so far? Okay, I think things look good. So I'm just gonna continue. Okay, so how are we getting all of these provider, signer, and the contract value is through this code. So we're just getting the provider here from our Ethereum object. Then provider.getSigner gives us access to the signer. This signer will then be passed onto this new ethers.contract. We are creating a new contract abstraction. We are passing our contract address. This is the ABI. I'll talk a little bit about it more in detail afterwards, but just think of it in some way of understanding what are the functions and the variables present on our contract address, because the language that is being used through Solidity, it's a higher level language. So in order to access the functions that we have, we need to keep this ABI here. I'll talk a little bit more about this in detail, but I don't want to talk a lot about it right now because it would be a bit confusing. So we are passing the contract address here, the ABI, and the signer that we are getting from the previous statement over here. And this is basically our connected contract. Awesome. Okay, so now I'm going to talk a little bit about what I just spoke about previously, that we have something called the event listener, and we're going to listen to the events. So as you can see, this dot on is the syntax that we use to listen to the event. We pass the event name over here. So if you see our file, mint.sol, you can check that the event is named new NFT minted. So we are hearing for this particular event over here. And if you can see the different params present over here, sender and token ID. So as I said, if you're listening for this event, then these variables will be accessible to us, right? So this variables, one is the owner, one is the sender and one is the token ID. You can see these two variables accessible over here. So from, that is the sender and the token ID. And whenever this event happens, this code, this snippet, whatever happens inside of this means like whenever this event happens, then what is our action? It's or defined here. Console.log will log this value, and then we'll alert that, hey there, we have minted your NFT and send it to the wallet. It may be blank, blah, blah, blah. And this is the link. And then we're just showing the link and we are passing our token ID over here. Okay. So this is whenever a new NFT is being minted, then this particular code snippet is being called and the action steps are this that are being called inside of it. Okay. So any questions so far?
Sneha, maybe later, whenever you have some time, what according to you could be some good resources that can be like a guide, step by step, how one should deploy like one should build the end-to-end app. If you can share anything from your experience, I'll also try to find something that can be helpful.
Yeah, definitely. I'm really sorry, folks, if a lot of this is too fast-paced. In the interest of time, I'm not able to cover a lot of things, but I'll be sure to share some things that can help you understand this better. Awesome. Okay, so then we spoke a little bit about how we are actually listening to the event. Now let us see what happens if you're talking about our mint function. Okay, so if we look at our code here, then we talked about the connect wallet button, and then we have our mint NFT button. So this is just a button that we are rendering, and its on-click behavior is to call this function, that is the ask contract to mint NFT. Now this is where we are actually going to call our mint NFT function that is defined over here, this mint token. So we're going to communicate from the front end and call this particular function on the smart contract through this function. Let us see how we're going to define this. Okay, so if we talk about ask contract to mint NFT. Okay, so as I said, same logic. We can probably skip over this part because we just covered this previously. Here we are actually using NFT storage. So if you folks were present on the in the IPFS workshop, this is just something that we are using the NFT storage package. This is an NPM package. You can install this, and this will allow us to directly upload our files. This is just the syntax that they have on the docs. Await client.store, and we are passing the name, description, and the image. That is the data that we are getting from the front end. Like from the input fields, we are getting this data, and then we are just passing it. And this is gonna upload this on the IPFS, and it's gonna give us the metadata.url. And this metadata.url is very important for us because this will allow us to actually provide this as a parameter to our mint token function. As you can see here, string memory metadata URI. This is actually what is going to get passed over here. And this is why this metadata.url is very important. I'm going to show you how the structure of this actually looks as well. But then we are just going to replace this IPFS thing with a blank. If this does not make any sense, it's fine. But basically what we are doing right now is that this IPFS over here, we're just overwriting it with our complete metadata URI string, this one. Okay, so now how are we going to actually call the function that is the mint token function with the parameters owner, that is owner of the NFT, and the second one being the metadata URI is through this function, where we are just calling our connected contract dot mint token, and we are passing the wallet address and the metadata URI. And whenever we are doing this, then we are doing await to wait for the mining to get complete. This is for that, this await over here. And then when it's done, we're just going to log that, okay, this is mine, and you can check the transaction over here. So this is more or less how the contract would look like. So if you have to call a function here, it just means that you get the connected contract dot the name of the function on your smart contract. It says mint token over here, it's mint token over here, and then the params that will pass over here, we are passing wallet address and metadata URI, and that will get matched to these params over here. So your wallet address is the owner, and the metadata URI is the metadata URI that is being passed over here. And then we'll just wait for the transaction to get mined, and we'll have our final transaction that we can see. So let us first see all of this once in action on our application as well. So things start making sense. Okay. So where is there you go. Okay, awesome. So okay, let's do one for you, Gyan. What do you say? What should I write as the description?
Okay, you can write cool Phoenix.
Cool Phoenix. Okay. By the way, I always made mistakes in writing the Phoenix spelling. I had to learn for coming to this tutorial that okay, what's the right spelling? And I'm gonna select big smile for you
Okay.
because that's the vibe I'm getting. So
Yes. Good one.
okay, where is it? Where did I save it? One second. I'm gonna actually download it again because I forgot where I saved it.
Oh, it was there. Oh, shucks. It's there somewhere. Yeah, just click on hi.
Oh wow, you got a really pretty one. Okay, so then I'm just gonna click on Mint NFT. Uh, yep. So now we have the MetaMask notification coming in.
So
So by
how are
the way,
these?
all of this, yeah.
Sorry, go ahead.
Go ahead, go ahead.
I was just gonna ask, how are these images being built? You have built them using some generative art kind of code, or these are just images that are uploaded on IPFS and are getting selected randomly, is it?
Yeah, so I'm using a avatar API over here, which creates, which takes a seed phrase. So your name is being passed as the seed phrase. So you'll
Oh,
get a random and a unique image avatar at every point of time. Then we upload this to the IPFS. When I'm clicking on the Mint NFT, I'll just show the logs as well for other folks to understand how this is happening. And then when we click the Mint NFT, we first upload it on the IPFS, we get the metadata string, and then we put that on our Mint NFT function so that we can dynamically generate our NFT. Okay, folks, so we have just pressed the confirm button over here. So the code for this is actually in just the UI part of it. You can actually ask me any questions about it. But again, in the interest of time, I won't be able to cover it, but I'll try my best that things start making sense. Okay, so as you can see on the console over here, I did speak about like how we are uploading on nft.storage. So you can see uploading to nft.storage and upload complete, minting token with metadata URI. I did speak a lot about this metadata URI and its importance for NFTs. NFTs are not just images, they can be video, they can be audio, they can be anything. But what are NFTs? Actually, they're just metadata. And this is why this metadata URI thing, this is very important. Like that asset that is being stored, this is where it's pointing to. And we're gonna just see what this is. This is just a JSON file. So this link that is being pointed to over here, this IPFS one, I'm gonna open this, I'm gonna show you like how this value is being set. So as you can see, it says name Gyan, description pool Phoenix, and this points to an image, which is this IPFS image that we just actually minted. So let me open this up to show you the image actually being okay. This is the image that Gyan got for her cool Phoenix. Okay, again, this is just saying mining. Please wait. This I definitely don't know why the Polygon testnet is being very slow today, and I'm not able to show you. I did show you the previous one on Sneha, and this is the very beautiful avatar that I got. But I'm not able to show you because the mining shows please wait, and the Polygon testnet is being awfully slow. But I would want you to just understand the logic that is being done over here. And this, if this would have been minted, then this would have shown over here as Gyan, and the description here would have been cool Phoenix, and this image would have been replaced by the image, this particular image. And that is how the whole minting NFT and the whole process would look like. So I would love to take any questions that you folks have till now. And if not, then we can move on to the second part of the application, where can you give an idea what is required for saying? So scaling Daps in itself, I think, is a huge challenge. Basically, whenever we talk about decentralization, it is very difficult to maintain scalability along with it. Uh, so, and if you're talking about AWS or these things, so decentralized applications are not hosted on AWS. Like they are on the blockchain. So whatever transactions that you're doing, everything is on the blockchain, and that is why it is very slow. Uh, yeah, that is why it's very slow for us to like get any value. Even on whenever you upload anything on IPFS, that is just decentralized storage, it takes time for it to fetch the values, because if anything is decentralized, that means that a lot of different bodies have to agree on something, like that there's consensus that's decentralized. And every time we are pushing something, like a new transaction is being made, it needs to be maintained, that copy of it needs to be maintained on all of the different nodes, on all of the different people who have the, like, keep maintaining the copy of the blockchain. That is why it is very difficult to get uh, okay, any questions? Yeah, as Gyan said, people are deploying the front end on AWS, but the smart contract side of it, the decent application side of it is on blockchain. You can actually make certain APIs that can be backend based. You do not need to store everything on on a decentralized manner. It does not make sense. You can store some part of it and some part on your decentralized application, where it makes sense to keep a smart contract to remove any sort of third parties or mediation, wherever someone can take power or control, you can remove the middleman over there and you can create smart contracts so that that logic can stay on the smart contract side. Please talk more about Avatar API. Okay, cool. Okay, let's take a minute and I'll just talk a little bit about the Avatar API that we are using here. Let me just go to the code. Okay, so the Avatar API that I'm using here, it is, where is it? Yeah, it's just Dice Bear avatars. So what I did was that I just installed an npm package for this, and then we have this create avatar function that I got from there. And these are the different styles that you saw in the drop down: adventurer, big smile, crude, all of these different styles there. So if you'll just go and I'll just show you the function where we are setting this. So this is the drop down where we have the different options, and whenever someone selects something, this on change function gets triggered, where we create this svg file, that is create avatar. This is the function that we imported from the npm package. e.target.value represents one of these values, whichever one we select. So based on that, this will just provide the styling, and this is the seed trace that will actually make it random or more centric to who you are, like, something random. So your name is being passed over here. And then we have the SVG. You can actually check the log. I'll show you. And the save SVG is the download function that we have written over here. So this is the logic for the downloading the SVG file, and then you can just upload it and do it. So you might have a question that why didn't I just choose to preview it or something? It is very difficult to preview SVG images on React. And even when you try to do that, React will try to not give you the exact image. It will try to like clip certain parts of it. That's why the better option was to just download it and then upload it again. That's why I chose to do that. Okay. Yep, let me actually just show you. Okay. Okay, so we have this minted finally after this being very slow. So let us just actually open this link. This is Gyan's NFT. Let us see how this looks. Gyan, this is a good time to take a picture and tell the world about this beautiful NFT that you have. So yeah, this is Gyan, and she's a cool phoenix, as you already know. So this is how any of you can actually I might just choose to what we can do, folks, and this is the reason why I actually chose this particular application and idea, is that we, being the Genesis cohort members of Phoenix Guild, we can create like a collection. This will be the identity of all of us, like this particular batch and all of our unique avatars, and with our names and our description, and we can just start a tradition or some sort, like this can just get passed down. that's like a class book sort of a thing, graduating class sort of a thing. So maybe I'll just host this application and all of you folks can go and try this out. You would require a little bit of testnet Matic. If you have questions about it, I can actually write down a whole readme on how you can get the testnet Matic and then run this particular application, because for every transaction on MetaMask, you'll need a little bit of the Matic or like the particular network fee for the gas fee that is being used to process the transactions. Okay, if you want to show all the NFTs that the owner owns, you fetch the info from the blockchain or from a database of chain. That is a very excellent question, by the way. So if you want to show all the NFTs that the owner owns, you can just create a function on the smart contract. And I'm actually doing something like this on my other contract, which we'll be talking about in a bit. So you can actually check how we are going to do that. And I'm going to talk about two methods actually. One would be something that will be staying like that. One will be reading from these events that is being triggered, and the second method would be to just read from directly from the blockchain. So you can actually do it in a lot of different ways. You can, depending on what kind of NFT is being stored. If it's very heavy, it makes sense to do it off chain. If it's not, then you can do it on chain. And yeah, a lot of things around that, but I'll discuss that. Yeah, as Jan is also mentioning here, that you can do it in a various sorts of ways, depends a lot on the type of data that is being stored. Okay, so that is pretty much about this part of the tutorial. Now I'm going to move to the second contract, and we're going to do a gratitude thing, right? For everyone here, whoever any person has helped and they feel thankful and they just want to, tip them a little bit of Matic. And I just showed you the calculation over here as well, that 0.001 Matic is 500 Phoenix Heart. So you can just select the amount in Phoenix Heart. You can select the receiver address, who is this for and why, and you can submit it. Okay, and this is how this thing will work. So let us see how this will look on our smart contract side of it. So before I talk on this, I just dive right into the code. Let us first understand what is being done over here. So we want to save some bits of information, like some gratitude. Every piece of gratitude, it is associated with a particular amount, the tip that you want to give, that Phoenix Hearts that you want to give. It is associated with the person who is sending it, the person who is receiving it, and a message like, why do you want to send it, who is this for, and why, that input box. So what makes sense here is to create a struct out of this gratitude thing. That is exactly what we are doing here. It is the amount, the sender, the receiver, and the message. Then we have a mapping that we have created over here, which says like the gratitude entries, and it says address, arrow, gratitude. What does this even mean? And this, like, what does this imply? This implies that mapping is basically a form of storage where you can just it is a form of a hash map. If I have to explain it, then it would look something like, you can, based on the address, your address will point to a particular gratitude. So if I'm talking about my particular wallet address, that is my sender address, it will point to one gratitude, one object of this struct, right? So every person given this can, like, every address or every person with a specific like address will be pointing to one gratitude, and we are keeping this as a mapping of gratitude entries. So how this will look like, I'm just going to show you this in the code if this is not very clear right now, but I'm just going to talk a little bit more about this later. But now we're just seeing our event. So this event is basically a new gratitude entry, and we are again sending some params. Who is the one who is sending the gratitude, to whom, what is the message associated with it, and what is the Matic amount associated with it. So this is just how we saw in our previous example for event. The constructor is empty here because we don't need anything. We're not importing any open Zeppelin classes over here. It's all empty. There's nothing to be done over here. Then we have a function, create entry. This is whenever someone presses submit on our main application, this is that function that we want to be triggered, which will take the message and the address of the receiver. So you might be asking here that, okay, but what about the particular amount or value? Where is that being set? That value is actually accessible through something called our MSG object. Okay, so this MSG object actually gives us access to who is the person who is triggering that particular transaction, that is message.sender, msg.sender, and what is the particular value that they are sending in the transaction, that is the amount of the current the money or the tip that is being sent, that is accessible through message.value over here. Okay, so this is how we're gonna access our sender, message.sender, and amount, message.value. That is why we don't need to pass them as parameters over here. We already have them, right? So this is how we are creating the function over here. You can see something like payable. So what does this payable means is that this value, whenever we add this payable modifier to any particular function, it means that the contract is ready to accept payments for this particular function. So whenever we send any amount, you'll see how this thing looks like. I'll show you in terms of the transactions, where the value is being sent, how is it being sent. But I'll come to that in a bit. So how are we first creating the entries over here is that I spoke a little bit about this mapping thing, right? That a particular address will map to an object of gratitude, and that is what we are doing. Gratitude entries, this address is synonymous to message.sender. So this is the syntax of that. So in this particular message.sender, we are mapping this gratitude object, where we are setting the message.value, message.sender, and receiver and message. So this is just the way of like keeping this. So for my particular address, there might be one gratitude object. For someone else's particular address, they can have another gratitude object over here, right? So we are just setting this value over here. So in this example, it means that we are assuming that one address can only have one gratitude, but you can actually even modify the code later to make it that one person can have gratitude for multiple people. So this, instead of being a single entity, will actually be an array, correct? So this is how we can keep all of this, like how we are just setting this value over here. Now let us talk a little bit about this function. This function is very important because it talks about actually paying the receiver the value. So this is first we are setting this is the call function where we are passing the value. So this is the syntax for actually paying any particular person, here the receiver, a particular sum of money, here the value, that is message.value. And we have put this receiver, we have wrapped this in payable because this is the way that we are making sure that the receiver is ready to ready to accept any sort of amount that is being sent. So in Solidity, you always have to make sure that whoever you are sending the payment to, are they ready to accept the payment or not? Otherwise, your transaction will fail. So this is why you have to make sure that anytime you try to pay someone something, you have to wrap them in payable construct. Like here also, if you're paying the smart contract or if you're paying the receiver over here. So this function will then return us a boolean, which will be like true or false. Okay, I'm really sorry if this is going a bit over time. I just checked the messages, but I'll just be done with this gratitude smart contract, and then we'll just move on to how this actually works on the front end side. Okay, so yeah, so we just checked our bull sent value over here, and this will just check this is like a true or a false, that is the value being sent or not. So next we have a require statement. So require statement means that if this particular, the first parameter, the first argument, if it's not true, then we have to set this error message that failed to send matic to receiver. So that is why we are just adding this check here to make sure that our value is actually, our entry is being actually created and the value is actually being sent. Otherwise, we can just send this error, fail to send matic to receiver. So now we are just emitting our event over here because we created this entry, we are emitting this event just like in our previous example, and we can just set up an event listener on our front end to get this. Okay, and now we have another function over here. So I did mention, like Sylvia asked a question right now, right? Like how can we get all of that information like from our blockchain, right? So here we have get your entries function, which is a public function which has view and returns over here. So what is this view mean? View basically implies a function that can read from the blockchain. So if a function only reads from the blockchain and does not write to the blockchain, you can add this modifier view to that function. There is another type of function called pure. So if you add the pure function to your modifier to your function, it implies that it does not even read or write to the blockchain. So view means only read, does not write. Pure means does not read, does not write. And if none of this is present over here, that means that there is also some write being done. Like in this example, where we are setting this value, this is a transaction. We are writing this to the blockchain. That's why we cannot add the view function over here. This will throw an error if you do this for create entry. So that is why we have a view function over here. And the returns is basically what we are returning. What is the type of data that we are returning? So here we are returning an object of gratitude, right? So as I mentioned, this gratitude entries, and this is stored in the message.sender, right? Our object. So this is how we are returning it. Return gratitude entries message.sender. So you can, if for example, if I create a gratitude and if Jan creates a gratitude entry, so based on our address, if we try to just return this, we'll get different gratitude values. Okay, so this is more or less about our smart contract. Some of this might be a bit difficult to understand at the moment, but trust me, it will make sense in some time. Okay, so now let us go over our app.js file and gonna talk about the setup event listener. This is the uh, second type of gratitude entry event listener that we defined over here for this event, new gratitude entry. So it's going to look exactly similar to how we did this for our new NFT minted. We're going to do new gratitude entry. We're going to listen for this event. Okay, and we are connecting our contact gratitude. We are passing the gratitude contact address over here and the ABI and the signer. Connected contract, listening for this particular event. We are passing these values over there. These are the arguments on our new gratitude entry event. So these values, address sender, address receiver, message, and amount. So this is all accessible over here. From, that is our sender, to, that is our receiver, the message, and the amount. And we are saying that, hey there, this amount has been sent from this address to this address. So this is what you will get. I'll show you how this looks like. And then we are just setting this particular gratitude object. This is just again React stuff, nothing to be like worried about. You might have a question over here. What is this? Ethers.utils.format ether does not make any sense. So this is just a way to format our amount to a ether based number. So this will actually return a number in something known as way. So just gonna write that over here. This is way. Okay. And this basically means like 1 ether is equals to 10 raised to the power, I think it's 18, I don't remember, way. So this will return the value in this, in a huge number. So to bring it back to the ether value, that is why we have to add this format ether there. I'll actually remove this and show you how that would also look, so that you have an idea that that huge number, and that is why we are using this format util ether thing over there. Okay, I have a question here. What is get all entries method used for? So get all entries method is basically used to get the gratitude for that particular like address. So if I have now saved the gratitude, if I click on submit button and I save a gratitude, then the get all entries gratitude would get my entries. Like for my address, that particular gratitude object, it will fetch back for me. That is why we have the get all entries method over there. I'll show you how this looks as well. I have not defined the function right now so that we can actually check it out together. Okay, and then we have our ask contract to enter gratitude. This is again very similar to how we have a mint function over here. So this will again, we'll just have our provider, then our signer, then our connected contract. We'll create our entry. We'll pass our message and our receiver. So only these two params were there on our smart contract side. You can check it here. Create entry takes two arguments, the message and the receiver. So over here we have the message and the receiver, and again we are just, and this is how we are passing the amount of money that we want to send. So I already told you, right, that this value is, we won't be passing this in our argument. Instead, we'll be sending this. This is how we are passing that value. And this is the value that we are sending over here. You might ask, what is the 0.001 by 500 logic? This is because the value that I'm taking there is in terms of the Phoenix heart unit that I showed. And this is just a calculation to get it back to the Matic value. That's why we have this value over here. So that 0.001 matic is equals to 500 Phoenix heart. That is why I've done this calculation over here. Do not bother about it if it does not make sense right now, but just showing how we can send the amount of money that you want to send for a transaction. That is how you're gonna just pass this again in this curly braces next. Okay, so you can actually send any value over here. I can even edit this out and I can show you if I custom write a value, then how that will look. But okay, first I want to just show you the basic one maybe, then I'll show this. Okay, and then again we are just one second. Yeah, we're just doing our normal mining, then we are checking our transaction. Okay, so these are the more or less the functions that are being used. Now let us see them, how they're actually going to look in practice, and we're going to check our console logs to see how everything makes like sense. Okay, just going to take a refresh on this page over here, and just post any questions that you have till now. Okay, some. Okay, this was working till now. I'm not sure what happened right now. Let me just take a reload again. Uh, did I accidentally delete or edit any code over here? Let me just try.
It's the property value of undefined. So I think something dot value is breaking.
One second. I think this has got to do with how badly intended my code is. Let me actually do something else to deal with this. Let me just do a git stash and then do an npm start again. Just give me a minute, folks. Hopefully we'll get this running. But yeah, I shouldn't have randomly just started editing things. Till then, I'll just take any questions as well. If there are any questions, we'll wait for this to work.
If you are not debugging live, that means you're not doing a live session at all. You have to, something has to break. And then you're be able to debug. That's
Yeah, I definitely know what the issue is. It's the indentation thing. Like my VS Code does not do well with this. That's what I just I like. This has happened to me many times before. When my VS Code editors has some issues and it just does some weird things with the indentation. Okay, so we have the app back again, but any questions so far? Otherwise, I can just go ahead with the okay, cool. So let me just go ahead with Gyan.
No, I was just saying if there are any questions, like even with respect to the contract, I think people can go. Otherwise, probably everyone may go through the recording again and want to kind of also look at the contract themselves. So.
Okay, so I'm just passing the values over here. So I'm just sending 5,000 Phoenix hearts. So if you see the calculation above, it says 0.001 matic is 500 Phoenix. So 5,000 should mean 0.01 matic, right? Like that is 10 times of that. And I'm going to send it to this particular address, that is my account 2. And copy this. As you can see, it says 1841 right now. So you're going to see how it's going to look like after we do this transaction. Who is this for and why? So this is just a fake simulation, but for the time being, I'm gonna say it's for Sylvia because she's listening very attentively. I've been observing. So, okay. So as I press submit, we have this MetaMask notification popping up. And as you can see, it says 0.01, like 5,000, that is 10 times of 0.001 matic. And we're going to do a confirm here. And then we're going to see how this whole thing looks like in terms of the transaction and the wallet and everything. So it's going to wait for some time. Okay. Ooh, okay. Not sure why this is being flagged right now. Let me. Okay, I'm going to change that value to 500. This is the overflow issue. So the number that is being sent, it's okay, just okay, let's try and submit. Okay, so pressing confirm. Okay, as you can see, it says, hey there, amount 0.001 has been sent from this particular address to this address. Okay, so, and this is like, we have set up this like value here. So we are just getting all of that from our event listener, and then we're just displaying it over here. So it says 0.001, 500 Phoenix hearts from and to the person, and the message is Sylvia over here. But how does this look like on the transaction side of it? So we're going to actually see the transaction and the trace over here. So just opening Mumbai Polygon scan. So this is the transaction hash that I got. You can see it on the code side where this is being shown. Yeah. So this is where we are getting this NFT transaction.hash value. And then we are doing a console.log. So whenever you call this particular function, this value, this NFT transaction, and then you can just do a dot hash to get this hash value, right, of that particular transaction hash. It says success. It says transfer 0.001 matic from this particular address to this particular address. Right. So this is how the transfer call works that we saw on our smart contract side, the dot call over here. Table receiver dot call value message dot value. And this is how we are sending the function, the value over here. So now let us talk a little bit about what I was explaining, like the way logic and that ethers thing. So if I Yep. So if I just remove this ethers.utils.format ether, then you'll get a huge number over here. Okay, this will again be formatted. Oh, please do not break now. Let me check. if this does not work, I'll open this in another editor and show you folks. Yeah, I don't know. Yep, this is issue with my VS Code. Just give me a minute. Let me open this up with just one or two. /npm start. I'm gonna open this on another editor. Okay, any questions so far? Any other questions? Okay, so I'm just gonna edit the amount and show you how that looks like. So over here, we're just gonna remove this, and I'm gonna show you the value that is being shown is going to be on okay. Yes, okay, it's working now. So yeah, so that was probably the indentation issue only on my VS Code. Okay, so I'm gonna show you how this will look if we do it. Yeah, let's just wait for this. Okay. So as you can see, it was previously 0.18 something, now it's 0.19. So we transferred the value. Sylvia is getting a lot of fake money as of now. So, okay. So confirming this transaction. Innovate. So this is one of the, yeah, as you can see over here, it says amount 1000 or something, a huge number, right? That's because the value or the units that is being shown is in Bay that I explained before. And that's why it's like 10 raised to power some 18 or something like that. And that's why the huge value, and that's why we have to first convert it to our normal ethers and then get it using the ethers.js library. Any other questions so far on this, or should we actually change some other things and see how the whole code would work otherwise? We just like tweak some things. So how about we write a function and just like log the value that we get from it? So intentionally I left out a function so that we can do it right now in real time and see how this will look like. And that is our okay, I should have opened the whole repository. Give me a minute. That is our
Sneha, why don't you give this
yeah.
as something for people to do and then come back to
Yep.
the question? So you have shared your repo anyways with the missing function, right?
Yes. So I do have a couple of future tasks that you folks can work on. So let me just share those tasks and let's end this session in the interest of time on what are some things that you can improve upon on this repository. And then maybe you can even create an issue or a pull request on my original code repo. And if all looks good, then we can merge that. And then that can be a really good open source contribution as well. Okay, so let us just discuss on what are the different areas that you can actually improve upon. So number one would be this particular function that is being mentioned over here, get your entries function. So I want you to call this function in our front end and actually just create that card that I have created down below. Maybe create that card by getting the information using this particular function, because this will return you the gratitude object, that is this object. So you can create the card based on this object instead of how we are getting it right now on the event listener. So that is one of the areas that you can work on. Another area that you can actually look to improve would be, instead of this mapping being towards only one gratitude, that is one person can only have gratitude for one particular thing, we can actually make it an array like this, and make it that a person can have multiple gratitudes, and instead of fetching here only a single value, this will actually give you an array, return all of the entries. So this is another improvement that you can make uh, on this application. Another thing that you can actually look into is that, what if the user wants to send something other than Matic to the receiver? What if we in the future we create another token of like Phoenix hard token or something? How would we send that? So that is another area that you can check. So that would be like changing some things over here to make sure that you can actually pay in some other token than the default value of the token that you want to send it to. And other changes could be on the NFT minting side. Some changes could be, for now, right now that we only have one function, mint token. What if we want to airdrop certain tokens, NFT tokens, to people who are not able to join today's session? So we can even create an airdrop NFT function to airdrop those tokens. So that is another way that we can expand on this. And similarly for that, we'll have to create another event over here. So yeah, that is more or less some of the improvements that you can make on the application. There are a lot of things that you can improve on the UI side of the application if you are front-end developers. So I'm not really good with design, as you would have already made out. But that is more or less for this particular workshop. I hope you had a good time. Yeah, I'm also going to share my Twitter. Do check it out. And I'm also building that thing that I mentioned. So do give it a follow if that seems interesting. And if you are looking for opportunities in Web3, then definitely consider like checking that out. Okay, 1 second. Let me just stop sharing because it's slowing down. Yeah.
Awesome.
Any other questions?
Do we have any other questions from anyone? Awesome. Early on, you had mentioned resources. Yeah. So maybe once we have some resources collected put together, we'll share it on our Telegram channel and also on the Discord channel for the Solidity Bootcamp. We can also, I think we can make this a little bit interesting. Like I know Sneha mentioned some improvements to the code. So I let her list out a particular set of tasks, and um, maybe we'll set up some bounties, we'll set up some budget, and if you're able to submit some of the improvements, yeah, we'll send you a couple of USDC just as appreciation. And yeah, thank you so much, Sneha. So this title of this workshop is a huge mislead. It's not just build an end-to-end app, it's build two end-to-end apps. So Sneha has shown us two dApps. How do they work end-to-end, like the whole contracts and including the front end. So this was great. I haven't seen such detailed explanation of how the contract functions are connected to the front end. So that was amazing. And thank you so much, Neha. I think you put in a lot of effort just building this out for this workshop. So we all really, really appreciate your time, your energy, and your ability to kind of teach and get the concepts. Sorry, my dog is licking. Yeah. So
I also want to say thank you.
Yeah, and thanks everyone for joining. And I really appreciate everybody. Like, even though we went over a little bit, I think it was totally worth it. At least I personally felt so. So, yeah, thanks everybody for having patience to kind of do this. And Sneha is available as a mentor on Discord as well for the Solidity Bootcamp. And she is generally busy building her startup, but she's more or less open to kind of connecting on Twitter and stuff. So, apologies for the noise. There's too much chaos in my house right now. But yeah, thanks everyone. And we'll share the recording as well once it is uploaded.